Hello, this is Britt Caswell with a video to help with algebra. In this video we're going to be looking at special right triangles. So special right triangles are going to be used as an introduction to a concept called the unit circle, which we cover in trigonometry. So it's very important that we recognize these two types of triangles. The first one is called a 30, 60, 90 right triangle because the angles are 30 degrees, 60 degrees, and 90. The other one is called a 45, 45, 90. Now these triangles are important because they carry a special ratio to their sides. So on a 30, 60, 90 degree one, the ratio is that the small side, or some people call it the short leg, the length, if we call that x, goes right across from the 30. Now if we go across from the 90, we get 2x. Okay, so the hypotenuse of this triangle is twice the length of its short side. And on this third side, across from the 60, we get the length x root 3. So if I know the length of my short leg, I can multiply it by the square root of 3, and that would get me the length of the long leg. And if I know the length of the short side, I can multiply it times 2, and I would get the hypotenuse. On a 45, 45, 90 right triangle, however, these two angles are the same. So what that means is that these legs are the same. If I want to find the hypotenuse of that triangle, or the angle across from the 90, I can just take the length of one of those legs and multiply it by the square root of 2. That being said, if I know the hypotenuse of this triangle, I can divide it by the square root of 2 to go backwards to get the legs. That same idea applies to my 30, 60, 90. So let's go ahead and let's try a couple of examples. So here we are. So I have a 30, 60, 90. And I need to go ahead and find my short leg and my long leg, okay? In terms of notation, I'm going to use SL to mean short leg and LL to mean long leg. Now, if you notice on our base one, okay, our example here, the length across from the 30 is just whatever x is. The length that's the hypotenuse is equal to 2x, and then the length that's across from the 60 is x root 3. So using that information, we're going to try to find the value of x and plug it in. So as I said, the hypotenuse here is twice the length of this short leg. So if if the hypotenuse is 20, then half of that hypotenuse is 10. So our short leg is 10. And then to get our long leg, you just take that short leg and multiply it times the square root of 3. So our long leg is 10 root 3 units. So that's not so bad. So let's try this orange example, okay? So I'm just going to call it a leg, right? Because on a 45, 45, 90, the legs are the same length. And then my hypotenuse. So if my legs are the same length, and this one's 5, this leg must also be 5. And then as I said earlier, to go from the length of the leg to the hypotenuse, it says you take the length of the leg and you multiply it by the square root of 2. So the hypotenuse is equal to 5 root 2. And that would be in whatever units you have, right? Inches, centimeters, dinosaur feet, I don't know, whatever you choose to measure with. All right, so another example. So on this purple example, I know the distance across from the 60. So I know my long leg, okay? That is across from my 60 equal to x root 3. Okay, so we still need to find my short leg, which is SL, and we still need to find our hypotenuse. our short leg across from the 30 is whatever x is. And if you look just at this example, 5 root 3, x root 3, that means that the x is equal to 5. So our short leg is 5 units long. And then according to our example, in order to get our hypotenuse, when we know what our short leg is, it says that you take 2 and multiply it times the short leg. So my hypotenuse is equal to 2 times that short leg, which is 5. So our hypotenuse in this case is 10 units. And then on to this hot pink example. So on this hot pink one, they've given us our hypotenuse. Okay, they've told us that whatever x times the square root of 2 is equal to 3. So now for these legs, we need to actually solve for x. So if you notice, I kind of created an equation there that I'm going to use to solve. This x is being multiplied by the square root of 2. So in order to solve for it, I'm going to divide both sides of my equation by the square root of 2. Now recall, with this fraction, it is an improper fraction because we have a radical in the denominator. So what we have to do is a process called rationalizing, which means that we multiply this expression by some value that's equal to 1, that's what all this orange is going to be, that would cause the radical to cancel out here. So if I were to multiply something by the square root of 2 that causes it to get rid of the square root, it would have to be itself. And then in order to keep that value equal to 1, I have to have the square root of 2 over the square root of 2, because any number divided by itself is 1. So when I go to multiply that together, the square root of 2 times 3 is just 3 root 2. And then in the bottom, the square root of 2 times the square root of 2 is just 2. So the length of both of our sides in this case is 3 times the square root of 2 divided by 2. And that's it. So if you know any of the legs on a 45-45-90 or a 30-60-90, or you know the hypotenuse on either of them, you can actually find any of the other sides. Until next time.